so you use a compressor to squeeze the gaseous Freon. But compressing gas creates a lot of heat. The compressed refrigerant may become hotter than 80 degrees Celsius, making it difficult to liquefy. No problem. You add cooling coils and a fan after the compressor to remove the heat. The hot, high-pressure gas cools down to about 45 degrees Celsius and condenses back into liquid. Congratulations, you've invented the condenser. At this point, you might wonder, if Freon normally boils at minus 30 degrees Celsius, why does it liquefy at 45 degrees Celsius? The answer is pressure. Increasing pressure raises a liquid's boiling point. For example, water boils at a lower temperature on mountains because air pressure is lower there. Under higher pressure, Freon's boiling point rises to above 50 degrees Celsius. So when the compressed refrigerant cools below that temperature, it becomes liquid again. Now you have warm, high-pressure liquid refrigerant. But sending it directly back indoors won't work because it is still warmer than room temperature. Then you have another brilliant idea. If increasing pressure raises the boiling point, lowering the pressure should lower it. So you pass the liquid refrigerant through a very narrow tube called an expansion valve. As the pressure suddenly drops, the refrigerant's boiling point falls to around 5 degrees Celsius. You then send this low-pressure refrigerant into another set of coils inside the room. Since the room temperature is much higher than 5 degrees Celsius, the refrigerant quickly evaporates, absorbing heat from the indoor air and producing cold air. This part is called the evaporator. Finally, the refrigerant gas returns to the compressor, and the cycle starts all over again. To improve efficiency, you add fins to both the evaporator and condenser coils. You also replace the fixed narrow tube with an automatic expansion valve for better temperature control. Congratulations, you've invented the modern air conditioner.